In our example so far, we've taken this small piece of steel here, say an inch by an inch. These warm and place them in a small amount of water. Now that's real small. This is more water, but still a very small amount of water. And what happened is the heat in here that went into the water was able to warm that water, wasn't it? Now here, it didn't warm all the way up to the middle, to the 50. In fact, the steel came down more, but still, it warmed the water quite a bit, didn't it? Okay? That's because we were using a small amount of water. Now the next example is very silly, but it proves the point. What if we took this little guy here? He's 1 inch by 1 inch, 80 degrees. We place him smack dab in the middle of the 55-degree Atlantic Ocean. And the question is, what will be the equilibrium temperature? Now, use your common sense. Is this little block of steel going to be able to warm the Atlantic Ocean? No, there's just too much water there, isn't there? So it's going to lose all of its heat. It's going to fall. It's going to fall at 55 degrees, and the heat that goes into the Atlantic Ocean is not really going to raise it at all, is it? So, using your common sense, then, the equilibrium temperature will be 55 degrees. It says here the 1 inch piece of metal can't warm the ocean much, can it? No. So when there's a lot of water around it, it's just going to go down to 55, reach that temperature of a huge amount of water around it, and that'll be equilibrium. By the way, here's your code, 321321. Now the same holds if you were to take that small piece of steel, 1 inch by 1 inch, now let's make it even warmer, 150, and it's in a room at 70 degrees. Is there enough heat in that little block of steel to really change the temperature of the room, which has a lot of air in it? No, can't, can it? It'll lose all of its heat, well, enough heat to go down to 70 degrees. It'll reach 70 degrees, and there it'll stay. And then won't lay a finger on the temperature of the room, will it? So the moral of the story, well, here it is. So the equilibrium temperature here, the equilibrium temperature is 70 degrees. The 1 inch piece of metal can't warm the room much, can it? The moral of the story is when you see a problem, there's a whole bunch, a gigantic bunch of air or water around the small object you're talking about, use your common sense. It can't really change the temperature of the surrounding material, can it? It's just going to cool down or warm up and reach the temperature, like here 70 degrees and here 55. That's it. Use your common sense on these. Bye.